In this lecture, I will share how to derive an expression for electric field at a point on the axial line of an electric dipole. Let us consider an electric dipole AB where minus Q is charge at point A and plus Q is at point B. As we know, this line joining both the poles of electric dipole is called axial line. Our question is, what is electric field at a point, let me call it P, due to both these point charges? I will calculate electric field due to minus Q at P. At point P, when I place test charge, that is always taken as positive, electric field due to this charge minus Q will be in this direction. Let me call it electric field E1. Similarly, when test charge is placed at point P, this charge plus Q will repel it. So electric field due to this second charge will be in this direction, and L2 E2 is electric field due to charge plus Q. We have to calculate resultant electric field at point P. Let me suppose this is center of electric dipole and distance of point of observation from center of dipole, let us suppose it is r. If L is length of electric dipole, then this center of dipole, let me call it point O, will divide the length into two equal parts. This part will be L by 2 and this part will also be L by 2. Now let's calculate electric field E1. Magnitude of E1 can be written as 1 upon 4 pi epsilon naught Q divided by AP square. Magnitude of source charge divided by square of the distance between source charge and the point of observation. Now what is AP? It is L by 2 plus R. So I can write 1 upon 4 pi epsilon naught Q divided by R plus L by 2 whole square. Similarly, I can write magnitude of electric field at point P due to this source charge plus Q as 1 upon 4 pi epsilon naught Q magnitude of charge divided by distance of point of observation, it is BP. So I can write BP whole square. Now what is BP? It is R minus L by 2. So I can write 1 upon 4 pi epsilon naught Q divided by R minus L by 2 whole square. So these results show that E1 is less than E2 because the denominator of E1 is greater and denominator E2 is smaller. So net electric field will be difference of the two. I will subtract E1 from E2. Let us put the value and simplify. E2 minus E1. Values are given. After taking Q upon 4 pi epsilon naught as common, I can write 1 upon R minus L by 2 whole square minus 1 upon R plus L by 2 whole square. After simple mathematics, I can write Q upon 4 pi epsilon naught, taking LCM, R minus R square minus L by 2 square whole square. In the numerator, we get r plus L by 2 whole square minus r minus L by 2 whole square. After simplifying the previous equation, I can write E is equal to 1 upon 4 pi epsilon naught 2 r q L divided by r square minus L by 2 square with whole square. Now Q into L can be replaced by P, that is electric dipole moment of the dipole. So E is equal to 4 pi epsilon naught 2 R P divided by R square minus L by 2 square. This is the expression for electric field at point P due to electric dipole EP. I can write in vector form this relation as E vector is equal to 1 over 4 pi epsilon naught 2 R P vector divided by R square minus L by 2 square whole square. Now we have to compare the directions of resultant electric field and electric dipole moment. As we know, electric dipole moment is always directed from negative charge towards positive charge. So this is the direction of P vector. Now what is the direction of electric field? Because E1 is less than E1 is less than E2, so E2 is greater. So net electric field will be from left to right, E vector. So direction of resultant electric field and electric dipole moment is same. So no need of putting negative sign here because they have same direction. Now let me consider a special case. Special case is that if point of observation P lies far away from the dipole, then R will be very greater than L, that is length of the dipole. Or I can write L by 2 is very less than R. In that case, in the previous expression I have derived for electric field, L by 2 square can be neglected in comparison to R square. After neglecting this term in previous result, I can write E is equal to 1 over 4 pi epsilon naught 2 R P divided by R square whole square. After simplifying, I can write E is equal to 1 upon 4 pi epsilon naught 2p divided by r raised to power 3. This relation is used when point of observation is far away from the dipole or when size of the dipole is very small. The same relation in vector form will also be simplified as 1 upon 4 pi epsilon naught 2p vector divided by r cube. This is the vector form of the relation when point of observation is far away from the dipole. That's all.